Okay, so this is the next part of the exponent rules lessons. All right, so first thing we want to go over is what's called the power to a power rule. Okay, so here's how we'll determine how that works. So consider this expression x to the third in parentheses. We have one power in the parentheses, and then we have another power outside the parentheses. Okay, rewrite without exponents. Well, this is going to mean take x to the third and multiply it by itself 4 times. That's x to the third times x to the third times x to the third times one more x to the third. Okay, simplify. We know about the product rule for exponents. We add the exponents. That's me x to the 3 plus 3 plus 3 plus 3. So that's going to be x to the 12th. Okay, you should notice that instead of writing all this stuff out, we just could have simply multiplied the exponents. Okay, so our rule is a to the x with the x inside the parentheses and y outside the parentheses. You should see that to simplify that, just simply multiply x and y. So that's going to be, a is going to stay, a to the power of x times y. Okay, so let's apply that. So x to the 10th inside, a squared outside, that's going to be x to the 10 times 2. That's going to be x to the 20th. Okay, so we have x to the 4th to the 3rd. That's going to be x to the 4th to the 3rd. And then we have a y to the 3rd to the 3rd. And then we have a z squared to the 3rd. Okay, so we just distributed the exponents. And now we'll simplify using our power to a power rule. That's going to be x to the 12th, y to the 9th, z to the 6th. Okay? All right. Simplify, we have a 5w on the inside and a squared on the outside. So the 2 is going to get distributed to everything on the inside. That's going to be 5 squared w squared. That's going to be 25 w squared. Okay, so now we have a quotient raised to an outside exponent. Same thing. So the negative 3 is going to get the exponent of 4. The a is going to get the exponent of 4. Okay? And the b to the 3rd is also going to get that exponent of 4. All right, so negative 3 to the 4th, positive 81. A to the 4th is just a to the 4th over b to the 3rd to the 4th. Again, we multiply the exponents. That's just going to be b to the 12th. All right, so number 4, pretty much the same deal as number 5. That's going to be x squared to the 5th over negative 2 to the 5th, y cubed to the 5th. Simplify, that's going to be x to the 10th. Okay. Negative 2 to the 5th, negative 32, y to the 15th. And when we have a negative anywhere in the fraction, it's customary to just bring it to the front. So this is okay, but a better way to write it, negative x to the 10th over 32 y to the 15th. Okay, but this is an acceptable answer as well. Okay, number 6, same thing, a little more work. So that's going to be 4 cubed, a cubed, cubed, over 3 cubed, a to the 7th, cubed, b squared cubed. Okay, and we clean all this up. 4 cubed is 64, a to the 9th over 3 cubed is 27, a to the 21st, and b to the 6th. Okay. And last one. Okay, so this is going to be 4 cubed a to the 7th cubed b to the 6th cubed over 8 cubed a to the 4th cubed 64 a to the 21st and b to the 18th over 8 cubed, 8 times 8 times 8, that's 64, 64 times 8, I don't know that off the top of my head, 2, 3, 48, 512, I thought so, 512, a to the 12th. Okay, guess what, we can clean this up. So we have an a to the 21st on top, a to the 12th on bottom, under in a fraction, so we're dividing. A to the 21st divided by a to the 12th is a to the 9th. Okay, 64 and 512, what can we do with that? Well, we can divide each of them by, let's do 2's, 32 over 256. Can divide by 2 again, 16 over 128. 2 again, 8 over 64. And these are each going to be divisible by 8. So that's going to be 1 over 8. Okay, so the final answer is a to the 9th, b to the 18th over 8.